Going from a design to an actual part you can use in your manufacturing process is easier than ever. But how can you quickly design a custom part that also utilizes off-the-shelf components? I'm Jeff, and this is Reinforced. So what's a vacuum gripper? A vacuum gripper is a type of end-of-arm tool, also known as an end effector. They're typically used in manufacturing lines to perform a specific function like lifting or sorting items. Today, we're going to be showing you how you can quickly make a strong custom printed part like this. We'll do a deep dive into the design considerations you need to make when designing for additive, like how to design internal chambers that maintain strong air suction, how you can design features to be compatible with off-the-shelf hardware, and how to properly utilize support overrides to your advantage. By the end of this video, we'll come away with a single part that's strong, reliable, and can be quickly installed. First, let's go over why this works so well as an application for 3D printing. First and foremost, 3D printing offers a pretty wide range to customize your fixture based on your needs. This means you can make something unique to your specific use case or product that will do the job perfectly every time. Next is the ability to reduce weight. 3D printed parts tend to be lighter than machined or off-the-shelf solutions. Heavy fixtures can put strain on a robotic arm and increase manufacturing cycle time, or require an even larger and more expensive robot to get the job done. Speaking of expenses, 3D printing can drastically reduce the amount of time spent machining or building the right fixture for the job. Lastly, 3D printed parts for end-of-arm tooling allows for simplistic designs that can reduce the amount of failure points. Take a look at this example part. Say we want to lift this part during the manufacturing process and transport it from one point to the next. The best way for us to do that would be using a vacuum gripper that would make contact with the product and raise it to its next process. While we conceptualized this application, we knew we'd need to incorporate some off-the-shelf components, such as vacuum cups, heat set inserts, and tube fittings. So I'll be sure to share exactly what we used. Let's dive into Fusion and start designing. So we're in Fusion 360, and we've got our part that we're going to be moving along the factory line. So starting off, we're going to be using our Insert McMaster Car component feature. In here, I'm going to be looking up our vacuum grippers that we'll be using and importing these as step files. We're going to do some initial rotations on the component so that it's set up for some mates. We're going to do this 6 more times until we have vacuum cups along the full length of this part. Once we have our vacuum cups joined to the component, we're going to start creating some planes so we can start sketching out our vacuum gripper. To create a plane, we're going to go through our Construct menu and choose Plane at Angle. Select our reference line off of the part. We're going to make a slight adjustment of 5 degrees so that the plane is perpendicular with the inlets of the vacuum cups. Once we have our plane, we're going to go through the Construct menu and offset the plane from the one we just created. We're going to make an adjustment of 1 inch just below this one so that this plane is aligned with the inlets of the vacuum cups. So now that we have our 2 planes, I'm just going to hide this top plane here. For our next steps, we'll just be using this middle plane. I'm going to use the Create and Create Sketch. From here, we'll start designing and building out the geometries for our printed part. Within our sketch, we're going to create some projected lines from the inlet fittings of each of these vacuum grippers. Once we have our projected lines, we're going to create some points. From here, we're going to create some lines so that we can offset the distance. We want these lines to be offset from the grippers by an equal distance. So we're going to go in, we're going to add some sketch dimensions. We're going to offset these by 1/2 inch. Once we constrain one, we're going to be using our constrain equal tool to make all of these lines the same length. Now that we have our lines offset from the cups, we're going to start building out some sketch lines for a 3D printed part. Let's speed through this. I'm going to exit out of the sketch now that it's done, and we'll move on to our next steps. So now we're going to create planes off of each of these vacuum grippers so we can start creating the 3D printed part. I'm going to use just construct and offset planes, and I'm going to be selecting this flat surface on each of these grippers. Once we have our planes made at the ends of each of these vacuum cups, we're going to be creating sketches for each of these for the internal chambers that will be going into our printed part. I'm going to start with doing a create sketch, and let's use one of these planes here. I'm going to actually project this circle so that I can get a center point and use this as our reference. So I've added in this diamond shape in here with 45-degree angles. The reason for this is once we're printing, to avoid overhangs for a printed part for internal chambers, we want to keep these angles greater than 40 degrees so that supports aren't automatically generated. Once we've done the sketch on one of these, we're going to do it for each of the planes going off of these vacuum grippers. Now let's focus on building out some geometry for a 3D printed part. I'm going to start by creating another sketch plane off the edge of our part that we're moving along the assembly line. Next, I'm going to create some offsets from the component here. I'm going to go to the Surface tab under Create and use our Surface Offset option. I'm going to select all the surfaces where the vacuum cups are in contact, and I'm going to offset them 1.1 inches, where the plane will then be coincident with each of these inlet fittings. Once we have this first offset, we're going to do it a second time so that we have some geometry to build out the 3D printed part. We're going to use offset again, select those same surfaces that we just created, and we're going to offset at a distance of, let's say, 0.7 inches. Now that I have the second plane, I'm going to do an extension so that we have a little bit more length on this part. I'm going to extend it 0.2 inches. Now that we've got our surfaces extended, we're going to do sketch planes that align with the inlets of each of the vacuum cups. I'm going to start by going over to the solids, doing a create sketch, and selecting this first plane. We are going to project the hole dimensions that we had created in the past, and we're going to get points created for each of these. We're going to do this for each of the vacuum cups. I'll skip ahead once I'm finished. Now that we have each of our holes, we're going to go forward and create a line between all of these so that later on we can use the sweep function to create a 3D printed part. Once we have our sketched line connecting all of these parts together, we're going to create another sketch that's perpendicular to this line so that we can start building out our printed part. I'm going to open up the plane that we had on the side and create a sketch from that. Now that we've got the sketch for our 3D shape along with the sketch of the spline line on the surface, next we're going to go through and we're going to use the sweep function here. Within here, we're going to use a single path and we're going to be selecting our profile from our sketch. Along the path of that sweep spline line. We want this to be a new component. And okay. Great. Now we have our 3D printed part and we're going to hide the bodies that we don't need and only focus on doing edits to the body that we just created. We're going to hide each of these vacuum grippers as well as our tooled part. We still have our planes from before where each of these grippers line up. We want to start creating holes that go into here so we can start working on the internal vacuum chamber. I'm going to start with this feature over here and I'm going to create a sketch on that plane. Within this plane, I'm going to project the hole going into the part from our vacuum gripper and start building some geometry, as well as creating that diamond shape to avoid any overhangs from being created when we start to 3D print this part. So now that we have our sketch, we're going to be using the extrude cut feature to cut into our part 0.8 inches. Once again, we're going to repeat this process for the rest of the vacuum gripper inlet holes. Now let's work on creating our internal vacuum chamber. I'm going to create a sketch off of this plane. We're going to be using that diamond pattern once again. All right, we have our sketch. We're going to finish this one and we're going to next use the sweep feature to create a cut. We're going to be going off of the sketch that we just created and choosing the profiles within there. So now that we have our vacuum channel created, I'll show you a section view to show how it's lined up with each of those inlet fittings for the vacuum cups. Our next section to make our part cleaner is by adding in some chamfers and fillets. These help cut down on these hard edges that we see along the part. So we'll add some in right now. And then lastly, let's add in some fillets as well to get rid of some of these hard cut corners. Now that we have our chamfers and fillets, let's focus on adding how this component would be attached to the end of arm tooling. We know that we want our tooling to be centered on this part when it's attached, so we're going to create a sketch. We're going to project this centralized hole here, and we're gonna add some more lines to it. Next, we're going to be using the hole tool to create the counter bore holes. We're going to be going off of the sketch plane that we just created. And selecting the 4 points along here. We're going to use a counter bore hole with a simple hole tap type and an angled bottom, so that it can fit our socket head screws that mount directly into our robot. I'm adding dimensions that are consistent with the screw size from McMaster. All right, here's our mounting points. Next, we're going to create another sketch plane for the vacuum plumbing from the robot into the end of arm tooling. I'm going to be dimensioning this hole 8.2 millimeters, which fits our plumbing hardware that is going to be imported in later in the process. Now that we have our hole, we're going to create a extrude cut with a distance into the part until it makes contact with the internal vacuum tubing. Let's go back and insert another McMaster car part. This is a tube fitting. Next, we're going to use a join function to make sure that this is aligned with our component. All right, we're almost done. Our next step is to use the hole feature for our heat set inserts going into our part. The dimensions that I'm putting on this hole are specific to the heat set insert that we're going to be importing. Now that we've finished one of our counter bore holes, we're going to do the same thing for the rest of the heat set insert locations. Skipping ahead, now that we have all of them complete, we're going to do our last step of importing our last McMaster parts. I'm going to do some orientation changes and start adding some mates. I'm going over to the assembly tab and then using joint to create some joints between our imported components and our finished component. I've got one created here. I'm going to do the same for the rest of the holes and continue from there. I'm going to copy and paste this heat set insert multiple times so that we have enough for the rest of our part. Now that we have all of our heat set inserts, let me unhide the rest of our components and we can see our finished product. And we're done. Now let's head over to our slicer. Because we're Markforged, we're going to be using Eiger as our slicing software. But a lot of the features that we're going to be covering can be used in other slicing applications too. To start, we're going to upload our STL file. We're going to be choosing our printer type. Let's use FX10 as a good example. We're going to do some manual rotations so that it fits on the print bed, and we're going to lock it into place. From here, we're going to be printing with onyx, as well as let's add some reinforced carbon fiber to stiffen up this part. One of the things we want to note, especially when using vacuum, is the roof and floor layers. Default in Eiger is 2 wall layers and 4 roof and floor layers. We're going to up these numbers to ensure that we're having sufficient vacuum when these chambers are being used. I've upped these now to 6 roof and floor layers and then 4 wall layers. From here, I'm going to hit save and slice the part. So now that our part is sliced and ready to go, let's validate and make sure that we're printing it the way that we want. Let's go into the X-ray view and look at the 2D and the 3D views. First thing to note, from looking at this part, we have fiber on the bottom couple layers and fiber on the top roof layers. Additionally, we have some support on the inside of this channel that we want to get rid of. To do that, we're going to go to the 2D view. We're going to scrub through the different layers until we start seeing the internal chamber where the supports are being generated. From here, you can see it's going all the way from layer about 160 all the way up to layer 244. I'm going to go back into the 3D view, go from layer 160 and highlight it all the way to layer 264 or so. In here, I'm going to create a new override and remove supports. I'm going to add some sketches in here and cover up those sections that we don't want. Next, just to validate, I'm going to scrub through these layers that we're using again and make sure that all of the areas of unwanted support are being covered by those sketches that we just made. Awesome, that looks pretty good. Going into this next section, let's look at the fiber that we have. From the 2D view, looks like we're using isotropic for the part, and there's some areas that fiber wasn't automatically generated. To increase strength of this part, I'm going to actually change this fiber type to be concentric fibers that follows the pathway of the part. For additional rigidity, I'm going to change these actually to 4 and apply this sketch. We just did that on layers 7 through 10 for the bottom. We're going to do that again for the top, change these from isotropic fibers to concentric fibers from the outer shell and up these to 4. Lastly, hit apply, and let's make sure that these are okay. These are on layers 383 to 386. Looks pretty good to me. Lastly, let's just look at the 3D view and kind of go through the whole part to make sure that our areas of override and our areas of fiber are correct. Next, we're going to reslice and save after that looks good, and we're going to wait to see our results. Now that it's sliced, let's check and make sure that our overrides were correct by scrubbing through this part. Looks good to me. Last step is to just press print. So let's recap. We took our product specifications and we designed our end-of-arm tooling based on these considerations. In CAD, we designed our part based on the off-the-shelf components, the grippers, the heat sinks, and the vacuum hardware. We offset our printed end-of-arm tooling based on the sizes of these off-the-shelf components. and we designed our mounting points based on the robotic arm. Additionally, for a 3D printing process, none of our internal vacuum channels had overhang angles greater than 40 degrees, and our hole diameters are larger than the minimum viable size our printer is capable of. Once the part is designed for the printing process, we moved over to our slicer. In Eiger, we increased the wall, floor, and roof layer thicknesses to have sufficient vacuum through the printed channels. Additionally, we added fiber for reinforcement, and we used support overrides for any unwanted supports that would be normally generated. And that's it. This part's ready for the factory floor. I hope you've enjoyed this video. Do you have a question? Do you want to see us cover a topic you've been dying to learn more about? Make sure to leave a comment. If you want to see more 3D printing tips and tricks, subscribe to our YouTube channel. Thanks for watching and happy printing.